Hello, this is Seokjin Kim, and this slide is for the presentation of University Final Project. I will introduce and cover these two problems because they cover a similar situation and physics versus code. I thought it is good to do both of them in once. The problem 11.27. The situation is that the current flowing the wire makes heat. For the gas, the book proposed temperature is 500 Kelvin and the derivative of temperature is 0 at R almost 0. There are two boundary conditions. First, the derivative of temperature is 0 and the temperature at end of wire is 300 Kelvin. Second, others are same but the derivative of temperature at the end of the wire has convection. Background knowledge. From the Wikipedia with proof, we can know that the time derivative of temperature is proportional to Laplace of temperature. If there is heat source, the term is added like second sentence. Also, the problem 11.28. The situation is so similar, but this time the variable is longitudinal and there is convection and radiation. There is three types of heat transfer: conduction, convection, and radiation. In this time, at the surface of the wire, the heat leaks to atmosphere with convection and radiation only. Problem 11.27 and problem 11.28 codes. This code is the code for second derivative of heat. This code is for the boundary condition. The YA means the value of the point A. Also YV means the value of the point B. The number inside the bracket means the value of dependent variable and its first derivative. Solid codes makes the range of independent variable and the initial guess. By doing this, we can obtain the temperature graph. Like this. And this is boundary condition of the condition B. And this is execution code. Problem 11.28. Differential equation and its boundary condition and its execution codes. For the visualization, as you can see, these are results. For the further visualization, I put the heat flux. The heat flux is proportional to the difference of temperature. For the visualization codes. For the code, I do not have any information about the heat capacity and the density. I put them in my test. Make the range of radius, theta, and z height with 3 by 3 by 3 tensor. For the transformation, I put the Cartesian coordinates and difference of radius, theta, and z. For the good visualization, I changed the sum of conditions. At the end of the wire, I put convection and radiation. Condition is that we have a reservoir of 500 kelvins at the center of the wire. If you do this, the condition consequence, the result is this. As you can see, the temperature are increasing. The convection and radiation cut off the increasing of the temperature, but not perfectly. This is not a steady state, so there will be some sinusoidal fluctuation. Not yet, but from here, there are some points that have higher temperature than the center of the radius. This peak will go to the end of the radius and cut by convection and radiation. If we put more condition that first of the height, the temperature would be 300 Kelvin by reservoir. The result is like this. For the more information of the code, I put FDT method. We put 300 Kelvin at the bottom, so as you can see, there will be inclination. You can see the inclination. And this is the end of my presentation. These are the reference of the picture and equation above. Thank you for attention.